Hello everyone, this is Pavan Kumar and today we will study class 10th electricity chapter from science. Right, this is your chapter number 12. So let us start without wasting any single minute. So first thing about chapter we will understand what is electricity. Okay, first of all we will understand what is electricity. What you can say electricity? Electricity you can say not path, part. It is not path, it is part of science. Part of science in which we study flow of current, about flow of current. Where we study about flow of current, that part of science is called electricity. This you can say. After this, the first topic which you have in your syllabus is electric current. What do you have? Electric current. What is electric current? Children, its formula is I is equals to Q upon T. I have written its formula because I want to explain this topic with the help of its formula only. This Q. What is this Q here? This Q is charge. What is T here? This T is time. And what is this I? This I is electric current. Charge, charge you have studied. There are two types of charge, positive and negative. Positive charge is represented by proton and negative charge is represented by electron. Right? After that, you also studied that one proton has plus E charge and one electron has minus E charge. What is this E here? E is the magnitude of one fundamental charge particle. 1.6 into 10 to the power minus 9, 19 C. What is this C? This C is unit of charge. What is this C? C is unit of charge and it is coulomb. It is coulomb. Coulomb. Its symbol is capital C. Now these all things I told you. Even after this, some topics are left here. Only charge we covered. This T is time. Its unit is second. And here you have current. Its unit is ampere, whose symbol is A. What is name? It is ampere and symbol is capital A. Okay. After this, let me write this formula again. I is equal to Q upon T. Now how can I define this electric current? We can define electric current in this way. Whenever it is given like this, you make denominator 1. Suppose time is equal to 1 second, then in that case, electric current will be equal to Q. That means electric current we can define in terms of charge. How can we define? That electric current is the charge flowing through conductor in 1 second. That means electric current is equal to the electric charge flowing through conductor in 1 second. Like this we defined electric current in terms of charge when we made its denominator equal to 1. This is the way to define. Now remember one more thing. If somewhere it is written like this, something upon time, like charge upon time is written here, whenever time comes in denominator, this time can be written in the form of rate of, right? We can write it like rate of. Now we have to check what is in numerator. In numerator you have charge. So what we can say, rate of charge. Rate of charge flowing, it is also called electric current. This is also a definition of electric current. Okay. So two definitions I told you of electric current. Now after this, we will study unit of electric current. What is unit of electric current? Unit of electric current is ampere. I already told you. Its symbol is A. Now if you want to define that how much is 1 ampere, then how can you define? You can define again using the same formula. I is equal to Q upon T. Current you want to define 1 ampere. You want to define 1 ampere when charge is 1 coulomb and time is 1 second. In that case only it is possible that 1 upon 1 gives you 1 ampere. Now how can we define? Let us see this. you can define 1 ampere by taking help of these all things. How can we see? When 1 coulomb of charge 1 coulomb of charge flows in 1 second. When 1 coulomb of charge flows in 1 second, it is called, then current is called 1 ampere. Very simple definition. Again you repeat, when 1 coulomb of charge flows in 1 second, then we can say electric current is 1 ampere. All the three things we have covered here in the definition. After this, next is device. Next is device by which we can measure electric current, flow of electric current. Flow of electric current can be measured by the help of ammeter. By ammeter we can measure electric current. Okay. Unit already I told you, ampere, but there are some smaller units like milliampere, microampere. This is the symbol of micro. 1 milliampere. Milli means 10 to the power minus 3. And after you have ampere. So 1 milliampere we can say is equal to 10 to the power minus 3 ampere. This micro means 10 to the power minus 6. And after that you have ampere. So these conversions you can use to convert from one unit to another unit. Okay. These are smaller units of electric current. Now the next thing is electric circuit. Next thing is electric circuit. We will see this. What is electric circuit? What is electric circuit, children? Electric circuit is path. It is a path on which electric current flows. Path where electric current flows, and that path will be continuous. That path will be continuous as well as closed. Okay. That path will be continuous as well as closed. We came to our book. See what topics we covered here. We covered this electric current as well as electric circuit. Right. After this, the formula of electric current we studied. You can see here one diagram. This diagram is electric circuit only. You can see this part. This part is bulb. This part is ammeter. This part is key. And this part is battery. Bulb is electric component. Ammeter we just studied. Its symbol is like this. It is key, just like you have switches in your home or in school. And this is a battery. This is a symbol of battery. I will explain it to you. Let us see what is battery. Next topic will be what is battery. Battery, children, remember, it is a combination. It is a combination of cells. Cell is represented like this. One edge longer and other edge shorter. Longer edge represents plus, shorter edge represents minus. If you make combinations of this cell, then combinations will be like this. Again, the longer side will be plus and the shorter side will be minus. So what is battery? It is a combination of cells. What is the function of battery? Function of battery is to maintain potential difference. To maintain potential difference. What is potential difference? We will study further. Okay. At its turn, we will study. One more thing I left here about ammeter. One thing I left here about ammeter. What I left? I left that ammeter always it will be connected in series. Just now we studied electric circuit. So in the electric circuit, how this ammeter will be connected? This ammeter will be connected in series. There are two ways of connecting. There are two ways of connecting. Either you can connect in series or you can connect in parallel. Either you can connect in series or you can connect in parallel. Other way is connecting in parallel. Now how can we connect in parallel and how can we connect in series? That I will tell you later. Just now you have seen the symbol of ammeter. So this is the symbol of ammeter. Plus and minus on one side, and on other side minus will come. Okay, so all these things we covered right now. Now the next thing is question. What is question? It is a numerical current of 0.5 ampere. Current is given, it is 0.5 ampere. What is next? Next is electric bulb for 10 minutes. For 10 minutes electric bulb is used. Time is 10 minute. Okay. Now in this question what are they asking? Amount of electric charge. Charge they are asking. Now we will see a formula which will relate these three things. We know there is a formula. What is that formula? Formula is I is equals to Q upon T. What is charge? Charge we have to find out. So from here we will find out Q by cross multiplying. It will be I into T. Now what is this I? This I will be 0.5 and time will be 10 minute. This 10 minute we will convert into second. 10 into 60. 10 into 60 seconds. So we will write here 10 into 60. It will be 0.5 into 600. And 0.5 into 600 will give us 300. What was this? It was charge. So it will be 300 coulomb. Right? This will be our answer. What is next? Let us move to the book. Okay, after this, there is one exercise. What is this exercise? What does an electric circuit mean? Studied. Define unit of current. That means 1 ampere. Also studied. Calculate the number of electrons. Okay, there is a numerical and number of electrons we have to calculate. Then, constituting 1 coulomb of charge. Charge is how much? 1 coulomb. Now, there is one more formula which you have to remember, and that formula is Q is equals to NE. What is this E here? This E is the magnitude of one proton or electron. 1.6 into 10 to the power minus 19. This is its value. Now N we have to find out. Okay, so from here first of all N will be equal to Q upon E. Charge is 1 and E is 1.6 into 10 to the power minus 19. When you will solve it, you will get answer 6.25 into 10 to the power minus, not minus, plus, this you will get plus 18. It will be plus 18, which you can write approximately equal to 6 into 10 to the power 18. That means this is the number of electron. This is the number of electron which is required to make 1 coulomb of charge. When these many electrons will come together, it constitutes 1 coulomb charge. See how big this number is, how large this number is. As you can see, 10 to the power 18 it has. The power is 18. Very large number. Okay. After this was numerical, and we studied one like a new formula, you can say. Now after this, what do you have? You have flow of charge inside a wire. What is flow? Flow of charge. We studied that in electric circuit, electric current will be flowing, right? So first of all, let us make an electric circuit. Let us make an electric circuit for you. Then I will be able to explain you in a better way. Okay. So this is my electric circuit. Here I connected one bulb. This is my ammeter. This is a key here, and here I will connect one battery. This is positive, this is negative. Now, if I said current will be flowing, then we should know the directions of current flowing. Remember, in the circuit, current flows from positive to negative terminal. If we say about positive charge, the same direction will be there. Positive charge also flows from positive to negative. What about negative charge? Negative charge, it is opposite. Negative charge flows from negative to positive terminal. Like here you can see electric current from positive terminal it came out, and towards negative terminal it will go. Same will be with the positive charge, but for electrons negative charge it will be opposite. That means you can say the direction of current and the direction of flow of electrons. It will be opposite to each other in a circuit. Okay. After this, we are studying flow of charge. As you read here, flow of charge inside a wire. How and why the flow of charge you will see. If suppose there is no current in the circuit, what do you have? You have charge in the circuit. Means if there is charge, there will be a current. But what we are supposing here? We are supposing charge. Suppose there is a positive charge. This positive, now you have studied that positive charge will be repelled by positive charge, and same will be with the two negative charges. But if there will be positive and negative charge, you will have attraction between them, right? So these all things we have to use here. Now how can we use? See, positive charge which we have represented here. This positive charge will be repelled by the positive terminal. But this is positive, this is positive. So this charge will be repelled and it will start flowing through the circuit like this, and will ultimately reach to the positive terminal, where this positive charge will be attracted by the negative terminal, right? After this, now you think, if this positive charge is pushed in this direction, a force is applied in this direction, and this charge is covering some displacement, or distance it is covering, then we can say some work is done on this charge. And who is doing that work? Actually, this battery only is doing that work, right? If this battery is doing that work, then this fact we will be going to use in to study one important topic. And what is that important topic? That important topic is electric potential. In electric potential and potential difference, we will be using this. Let me make one electric circuit again. Okay. This is electric circuit, space for battery, component, ammeter and key. Okay. Here we have bulb. This is place for ammeter, plus minus. This is key, and here will be our battery. This is plus, this is minus. Now about the charge which we are talking here. Suppose the value of this charge. It is equals to plus 1 coulomb. Okay. Still there will be some work done by the battery on this positive charge, right? So whatever work will be done on the positive charge. Okay, before I complete, let me take 2 points. Suppose this point is B and this point is A. Then during the journey of charge in this direction, it will pass through A and B. But we will talk between A and B. It will pass through A and B, and ultimately it will go to the negative terminal. But here we will talk that from A to B, what was its motion, what type of motion it was performing. So when it starts from A and starts going towards B, you know that some work will be done, and since that work is done on unit coulomb of charge, unit positive charge, then this work only will be called potential difference. What is potential difference? We defined potential difference here. Potential difference is equals to that work done which is done on unit positive charge when it moves from one point to another point. This is the definition of potential difference. Okay. After that, what will be electric potential in that case? What will be electric potential? Let us see this. What will be electric potential? So electric potential, in the same way like we defined potential difference, we can define electric potential also. See, We said that between any 2 points, like A and B, again we are taking, between 2 points there was a potential difference. Then remember children, if between 2 points we were finding potential difference, that means we can say at each point there will be some potential. At each point there will be some potential, right? So that only is known as electric potential. But how will we define it? We will define it like this. Potential difference we talked between 2 points. Potential we talk for single point. Then in place of other point, what we will take? We will take infinity. So VA minus V infinity, it gives us potential. It gives us potential. Okay. Now you will say, sir, why infinity you have taken? Because we consider that at infinity potential remains 0. If we consider that potential remains 0 there, then what we can write? We can write VA minus 0, which gives us VA. VA means potential at a single point, which is called potential only, right? So understood. Now let us talk about them in brief and differentiate. Okay. About electric, about potential we will write here, and about potential difference I will write here. Potential difference. Okay. Potential difference was the work done on unit positive charge in moving from one point to other. Like this we defined. What is potential? Potential is the amount of work done on unit positive charge in moving from infinity to a point. Infinity to a point. This is the basic difference. This is only the basic difference between the two definitions. Now we will talk about their units. What is unit of potential and potential difference? Unit is volt. Both the quantities have same unit. Volt symbol is capital V. Now volt symbol is capital V. Potential difference, its symbol is capital V. Potential, its symbol is also capital V. So all of them are having same same alphabet. By same alphabet they are represented. Symbol is same. Like we defined 1 ampere, how can we define 1 volt? Like we defined 1 ampere, how can we define 1 volt? With the help of its formula, potential difference formula. Potential difference formula, you remember, it is equals to W upon Q. It is equals to W upon Q. Okay. Now you want to define 1 volt potential difference. It will be when work is 1 joule and charge is 1 coulomb. Charge is 1 coulomb. Now in the definition we have to take these all numbers. How can we define? When 1 joule of work, by 1 joule is work only. So when 1 joule of work is done on 1 coulomb of charge, 1 coulomb of charge between, or you can say from one point to other, then it is called, then the potential difference is called 1 volt. Simple. Let us repeat once. When 1 joule of work is done on 1 coulomb charge in moving from one point to other, then the potential difference is called 1 coulomb. All the 3 points we have taken in our definition. Okay. So this was the definition of 1 coulomb. After this we will talk about voltmeter. What is voltmeter? Voltmeter is device. Now what type of device it is? This device can measure potential difference or voltage, you can say. Voltage is other name of potential difference. Okay beta. Also we can say that by voltmeter we can measure potential. Like this also we can say. We studied that ammeter was connected in series. Remember children, voltmeter will be connected in parallel. Voltmeter will be connected in parallel. Right? Now after this we will move to our book and we will see is there any topic we left. If we left we will cover that topic also. So potential difference, its formula we studied. We studied 1 volt, its definition. Okay, now we have one question. What is question? How much work is done? Work they are asking. How much work is done? Okay. In moving 2 coulomb, 2 coulomb means charge is given 2 coulomb. Okay. Now potential difference 12 volt. Potential difference is 12 volt. Now you check what formula relate these three quantities. You say, sir, just now you taught potential difference formula. It is W upon Q. So from here we can say W is equals to VQ. And what is V? 12. What is charge? 2. So 12 to the 24. It was work. So work will be in joule. This is your answer. Check once. Yes, this is the same answer. After this you have one exercise. After this you have one exercise. What is this exercise? Name a device that helps to maintain a potential difference across a conductor. Now, potential difference. Children, in this formula only you see, if work will be 0. If work will be 0, then what will be potential difference? Potential difference will also be 0. That means to maintain potential difference, what is important? Work is important. And who was doing this work? Who was doing this work? Remember, we studied. See here. This work was done by battery. So what is required? What is required, children? To maintain potential difference, a battery is required. Okay. So this will be the answer of first question. What is second question? What is meant by saying potential difference between 2 points is 1 volt? That means they are saying that what is definition of 1 volt potential difference? This also we defined, just defined. How much energy is given to each coulomb of charge to pass through a 6 volt battery? Now potential difference is 6 volt. Charge, each charge they said so charge is 1 coulomb. And they were asking how much energy is required. Then remember children, energy is equivalent to work. That means work we have to find out. Potential difference formula is work upon charge. Work from here it will be VQV. What is V? 6, charge is 1. Answer will be 6 volt. So work or energy, you can say energy will be equals to 6 volt. Okay children, 6 volt energy I said. This work will be in joule, right? So we have to rub this V. What will come here? 6 joule. 6 joule of work will be done, right? Let us move to book. After this what we have? Circuit diagram. This we will study in the next class. Okay, or you can say next part of the video lecture. So till then we revise all these things. If you are not getting anything, you can ask.